In Unit 6, we will first review Ohm's law. Ohm's law talk about a simple relationship between voltage, current, and resistance. Voltage is equal to current times resistance. Ohm's law is one of most fundamental and important laws in the fields of electricity and electronics. Again, it describes mathematically how voltage, current, and resistance in a circuit are related. So the unit of each variable over here, voltage has units, volt, and current, ampere, resistance, ohm. So let's consider if voltage across a resistor is decreased. Let's assume resistance does not change. Then the current through the resistor will, so voltage decrease and the resistance no change. How about the current over here? Based on the linear relationship, current will also be decreased. Now let's think about if voltage is increased. Still keep the resistance same, then the current will also be increased. This is the Ohm's Law Triangle. So we usually use this triangle to help us remember Ohm's Law. Because if you look at this triangle, you will see voltage is equal to current multiply resistance. And the current is voltage over, see this line over here, so voltage over resistance. And the similar thing, resistance is equal to voltage over current. And here listed the correspondence units. In this slide, if you click here, you will see this Ohm's Law Demo. You can see if you keep the resistance the same, for example, we can change the voltage, and let's see what will happen in the current. If you increase the voltage, the correspondence current will also be increased. If you decrease the voltage, the correspondence current will also be decreased. So similar thing, let's keep a constant voltage, let's say 5.4 volts. If we change the resistance value, we can increase it because I multiply R is equal to V. So if you increase R, then I will be decreased. If you decrease R, then I will be increased because the multiplication result will keep same, 5.4 volts. Okay, now let's review power. Power. The general formula for power is power equal to voltage times current. If you talk about power on a resistor, we can use the Ohm's law to derive two more equations. For example, let's review Ohm's law. It's voltage equal to current multiply resistance. Suppose let's use that. So since you know voltage is IR, you can just replace V by IR. Then you will get power equal to I squared times R. Similar thing, you can replace I by V over R. If you replace I by V over R, then you have V squared over R. Those two are applied to the resistors. So for a resistor, you have 3 formulas to calculate the power. And in this chart, the formula for power, voltage, resistance, and current are summarized here. For example, for the power, you can see power equal to I times V, also equal to V squared over R, and R times I squared. And similar, we can derive other formulas. So when you need to calculate voltage, current are related to power, you can use this formula chart as a reference. Okay, so energy and power. So what is energy? Energy basically is talking about the ability to do work. The unit is joules. In short, we just use J to represent it. Power is the rate at which energy is used. So power is energy over time. Unit, energy is in joules, and the time is in second. Power unit is watts. So 1 watt over here means the total amount of power when 1 joule of energy is used in 1 second. Electrical energy is billed to customer in kilowatt hours. Let's think about, is this unit of energy or power? So first, let's look at this unit. Kilo. Kilo is just a prefix, 10 to 3. And watt is a unit of power. So when someone first sees this, they may think, okay, this is a unit of power. But don't forget, you have hours over here. That means that is watt times hours. Think about here. So watt times hours. If you time those two together, you actually get energy. So your bill is actually based on energy, not the power. For example, if you bought a TV, and that TV has a rating in certain watts, but if you don't turn on the TV, if you don't use the energy company will not charge you. So first, let's talk about some prefix. Why we need prefix? For example, the charge of 1 electron is 0.0000. You can count how many zeros, and then 1602 coulombs. So many zeros. It's not easy to read. So people use a prefix. If you use a prefix, how to use prefix? If the original point is over here, if you move the point to here, you actually move it to the right 19 times. So that's why in scientific notation, you can write it as 1.602 times 10 to negative 19. Similar things, if you have 1 coulomb of charge, you can count how many electrons in it. It's this amount of electrons. So you can see so many zeros after the number. And if you use scientific notation, the original dot is over here, so you move the dot to the left until you move it to here. That is actually you moved to the left 18 times. So that's why you have times 10 to 18. So scientific notation just save some time to write all the zeros. And scientific notation has two parts. A value part, which is a number between 1 and 9.9, and times 10 raised to a power. For example, if you have this number, the original dot is over here, point is over here, so you move it to the left by 1, 2, 3, 4, 5, 6, 7. Then you have a number 9.2 that is between 1 and 9.9, and then times 10 raised to a power of 7. The prefix are listed over here. You don't need to remember everything for now, but you better remember something we used very often, like kilo, 10 to 3, simple is K, mega, capital M, and giga, and tera. The tera, giga, you're probably familiar with it because when you buy a computer, your hard drive now can get to tera, certain terabytes. Yeah. And on the other side, yeah, centi is 10 to negative 2, milli 10 to negative 3, micro over here, nano pico. This is a Ohm's law example. You can see this is a pretty simple circuit. You have 10 volts and 10 ohm connected in series. And the question is, what is the current? What is the power dissipation on R? So the current based on Ohm's law. Just to review the triangle V is on the top and there's a line and you have I here and R here, imagine. So I is equal to V over R. And then, so V over R equal to 1. Don't forget the unit. So V over R equal to 1 ampere. And the power. What is the power? Power, actually, you have 3 formulas to calculate because this is a resistor. So one formula is the voltage times current, because you just calculate the current. So voltage times the current, you should get 10 times 1, so that is 10 watts. And also you can try the other 2 formulas. This one, the easier thing to use is voltage over R, because you know them already. So voltage square over R. So voltage square is 100 divided by 10, you got 10. So power should be 10 watts. Similar things in this second example, you can think about it. In this time, you know voltage, you know current, they tell you the current. And they're asking you what is the resistance. Based on Ohm's law, R is equal to V over I. So V over I, 10 divided by 4 milli. Don't forget what is a milli. Milli is 10 to negative 3, but there's a trick over here. 1 over milli is actually kilo. So 10 divided by 4 is 2.5, and 1 over milli is kilo, so kilo ohm. So 2.5 kilo ohm. And they also ask for the power dissipation. So same thing, this one, the easy way to calculate power is because you know voltage, you know current, just multiply them together. So that is 40. But don't forget the prefix. So the answer should be 40 milliwatts.